Alright, so example 5 for volumes. And this one we're going to talk about the fluid source node. And this is generally the node we're going to use the most to set up our fields for actually sourcing things into Pyro. You can do a lot of things with this node. I'm going to try to go over most of the important things. Let's start off with scalar volumes. And let's start off with the top part here with method and source attribute and stuff like this. So, first of all, we cannot look at the method here. So we can source things into this node with a couple of different methods here. You can take build SDF from geometry, which is like a default. Then you take the polygons and you basically make that into volume. You can also stamp points, which means that it will grab the points. So if I scatter points on the sphere, it will basically grab those points, which can be really useful sometimes. You can also choose to sample volumes. So we can do a VDB from polygons. You can sample volumes as long as it's a fog volume and the field's density. Then you're gonna source the volume. But I usually stick with either stamping from points or SDF, or build SDF from geometry. But let's build from geometry this time, okay? So here we can define which fields we want to create. There's a lot of different fields we can create. I'm gonna add a couple of more here. So we can do a vel, we can do a fuel, we can do a temperature. These are the most commonly used ones, okay? Actually, vel you don't want to visualize. You might want to turn it off. It's still there, but you just turn it off. Same with fuel and temperature. Honestly, I usually only visualize the density field. The density field will be the smoke. The vel is the velocities, or the vector velocities in the volume. Fuel and temperature is used together to make things burn. The fuel and temperature will create a field called a burn field. But this happens in the solver, so we don't really create it right now. But yeah, because it's like if you imagine it to be fuel and you put temperature to fuel, a really high temperature will ignite the fuel, basically. But if we remove the fuel, we still kind of want the temperature in there, because the temperature can help us make smoke look hot. You know, like when smoke gets heated, it gets faster, maybe less dense. These kind of attributes can add to our simulation. So usually we want to keep a density, vel, and temperature. These are the three main fields we always want to have. Sometimes you can disregard both vel and temperature and just go with the density, but you kind of have to make your own choice there. So that's it for these fields. That's kind of how they work. You can multiply them here with a scale. You can choose how to visualize them, and yeah, that's it basically. So I'm gonna remove these just to have the density. Then in here, in settings, it's the first time down here, you can kind of define the resolution. So division size kind of directly affects how many voxels your volume will be. So right now I have division size set to 0.1. And that means that our voxel count is 19 by 19 by 19, and the total voxel count is 6,859. If I put this to 0.05, so we can see that our voxel count is 34 by 34 by 34. The voxel count is 39,304 now, so that's quite a lot higher, but it's quite cool. Let's see what else we can do. In the visualization, we can't really do anything that interesting. In SDS from geometry, if we actually do have this method set to build SDS from geometry, we want to look at this tab. If we have stamp from points, we kind of want to look at this tab. But for now, we have SDS from geometry, so we're gonna look at this. Minimum distance means that it's like how close to the surface you are sourcing from. Sometimes I want to do this, I check off empty interior, so it becomes like totally like not an empty volume inside. it's a volume throughout, which can be kind of useful sometimes. But yeah, here you can kind of do a dilation of it, or erode it, kind of define the edge of it, feather the edge a little bit. You can add noise, which is really cool. You have to check this. And then we can turn up turbulence influence, and we can turn down the scale of things. And if you now scrub through, you can see that you have noisy things going on, which is going to help a lot for making things look pretty when you actually simulate, because having these like initial things in your source is super important. So yeah, there's a lot of things we can define here. Sharpness, we can define the amplitude, we can do the pulse duration, which means how long, what kind of frequency our noise will move at. So if it's 0.5, it's going to move kind of fast. If it's 10, it's going to move super slow. So let's put it back to 1. That's it. And then the motion blur, if something is super fast moving, you can kind of motion blur your volumes, which will give us a way better way to source things. Because sometimes you will see the sourcing from a moving object can be kind of tricky, because if it's moving really fast, it's really hard to get a proper sourcing on each subframe. So this can definitely help with that. There's some tricks to go around it, but if nothing else works, this usually does the trick. But there's some ways, because it's quite slow if you actually do turn this on. But there is a couple of ways to do it a little bit faster. And yeah, step sampling, I don't know. But if we do take from points instead, and we change this to stamp points, and we do stamp points here, because now this one won't be available for us, SDF from geometry, only the stamp point. Now here we can define the distance from the points, like what P scale they have basically, and also the threshold of sampling. Yeah, that's kind of it. There's a lot of things you can do with this, but these are the general things you want to keep in mind: the fields, the method of sourcing, and the division size, and kind of the noise. Those are the most important things. So yeah, that's it for our fluid source. Now let's start with Pyro. Thank you.